So what we're going to do is start off this unit. Is I want to play a little game.
Yeah.
So back when I used to dabble with computers and computer programming, way back when, we used to write little programs, right? And with programs, what you have is you have an input and an output. And actually a lot of programs, actually I'm just start learning programs actually very mathematically based. But what happens is you have an input and you have an output. So what happens is I wrote this program, you type in a number, and then it spits out a number. Right? And you were supposed to figure out what the program was doing. Okay? So we're going to simulate this a little bit. So we have an input and an output. So the input is what goes into the program and the output is what comes out. So the input for this program is an integer between 0 and 10 inclusive. So you can have 0, you can have 10, right? So you type in this number, you put this number up, and then we'll give you an output. Okay? So I have a volunteer. The first input. Paul.
Does it have to be a decimal?
Integer
Okay.
between 0
Okay.
and 10 inclusive. So you can have 0 and you can have 10.
Alright. 6.
6. Black. So 6. The input is, so the output is 9. Okay, write this down. So I want you in your notes, write down this table. Right? Or just a little T chart, just input and output. So I have an input of 6, the output is 9. Anybody know what the formula is, what the computer program is doing? Guesses? Anthony? Adding 3? Looks like it. Good, so what about another input number? The volunteers are input number. Jenny? 7. Actually, no, the output was wrong. The output's actually, sorry, 15. So for 7, the output is 17.
Oh yeah, I know.
That's easy, so you got it. Won't keep it to yourself. So what's another input? The volunteer's another input.
32.
Anthony? 10.
Can I say the answer?
I see a lot of smiling faces out there. Smug faces. Okay, one last input. What's the volunteer? One last input.
23.
Nicholas?
4.
4. 4. So what do you think the output's going to be? Brian?
11.
The output is okay. So here we have a relationship. We have a correlation between your input and the output. Which one is the independent variable? Which one is our independent variable? Christina.
D. Oh. In output. No, in output.
Which one is it?
I told you output. It's output.
The output is the independent variable, so the output affects our input.
So ask me a question. Yeah. No, never mind. In.
So it's input enough.
Yeah.
So the input affects the output.
Yeah. Yes.
Yes, okay? So that's how we determine which was the independent variable and dependent. So here, independent variables input and the dependent variables output. So what I want you to do is I gave you graph paper. One thing I want you guys to, oh, I should bring this light up later.
What were you doing?
I don't know what the pattern is. We'll talk about it a little bit later. But why don't you take those 4 points and just graph them in that order. So So we did this in green. So here I'm going to label my scale. The scale is going to be by 4. So what's my first point? What's the first set of numbers under? 6 and 15? 10, 12. Whoa. I missed 8. 4, 6, 8. Okay, so we have 6 and 15. So I'll point right here. What's the other one? 7 and 17. So that's what's in there. What's the next one? 10 and 23. 6, 8, 10. That's going to put us somewhere up here, I think. And the last one was. What was the last one? 4 and 11?
Yeah. What?
Right? So we have a little scatter plot of our little program. Right? Independent variable, which we call on our x-axis. This was the input. And across the y-axis was the output. Yeah, so I just didn't finish labeling. So 8, 10, 12, 14, 16, 18, 20. Okay? Let's try the next program. Oh, do you need that?
Yeah.
It's just this normal scatter plot of 4 points. Right? They did scale across the bottom and went by 2s.
Can we not make this our
How do you know
paper
which-
sensibility? Because
Yeah, it's hard to.
Is it? Okay, you have another graph here we try to do this on.
So that's not-
But it's just 4 points.
Yeah, but it's just easy.
Okay, whatever. Okay, so let's go back to our second program. So who wants to volunteer input now? Matthew.
3.
3?
We.
The output for this one is. This one really is 6. Okay, how about another input? Right. 10? Did you say 10 last time? No, it was Anthony. 10. And the output of that one is. Okay, another input? Nicholas?
8.
8. The output of this one is 16. And you guys got the program figured out?
Yeah.
Okay, so what's the one last input? Between 0 and 10. Call.
6.
6. And what do you think the output's going to be?
42.
You'd be incorrect, Paul. We might have to put you in review on that. What's the output? Vince, what do you think?
12.
Okay, so same thing with these ones. Do it on a separate graph. Right, I'm going to do mine on the same one. What do we got?
Not the same one.
No, do it on a separate one.
3, 10, 8,
So we got 3, 6, which puts us around right
6.
here.
We have to do another one?
You don't have to, okay, one thing when you guys do your scale, you don't have to label them completely. All you need is like the first 3 numbers.
Oh, really?
2, 4, 6. So just that we see what the interval is. So then 3, 6, 10, 20.
Wait, what is that?
Interval is the value in between each one. So here I have intervals of 2.
Oh, but what if like it goes now 20, it goes to 20, but some are like higher than 20, so do we just like
Yeah, I had to extend that one because somebody threw me. I didn't expect anybody to say 10. Anthony.
Clear folder.
8, 16.
Wait, we do this on the same one?
You do it on a separate one. And last one was 6, 12. 6, 12 right there. Yes.
If there's no negatives, do we have to even write it down? Or-
You still you should because we have x, y, and negatives. The grades I gave you have an origin, which is 0, 0. So you still label the negatives. Again, but you only need the first 2 or 3. Okay, so we go to that scatter plot. Right? Is this anything different than you guys learned before? No, so it's a little bit of a review. Next program. Who wants to pick a number? Who get? 7. Blue. Next one. Nothing.
3.76.
Integer between 0 and 10. Input rejected. That's what my computer program would say. Input rejected. Right. 1.
You just got beat up by a 1, Brunetta.
Yeah, 3.76 is better than 1.
Everybody see what the pattern is yet? What the whole program is doing? You thought you knew it? Just threw you off, 1 and 0. Nicholas.
-3.
0.
Okay. An integer between 0 and 10. They put rejected. Looks like we have to go back to our first lesson on numeracy.
That's not.
What an integer is between 0 and 10. Dean.
9.
9.
I like that number 8.
That's the only one I
Well,
What?
Easy. I don't know what
What?
this is.
24. So input is 9, output is 24. So anybody figure what the program is doing yet?
I get it.
Okay, one last number. Who wants to Thomas. 3.
No. Killed it. It's supposed to be 6 in each one.
Oh, I get it. There's 6 and 2 there. Thought there was 6 and 2. It's pattern.
Yeah.
Okay.
So input is 3, output is
Oh, there's a
6.
6 in that. It's him.
Well, I forgot to ask. Who actually guessed it would have been 6?
No, he just
Anybody
said,
guessed?
you should fix it.
Oh.
I like the number 6.
Okay. So let's plot these ones again. So we have 7 and 18. 7 and 18 brings us here.
Is it minus 3?
Sorry?
Is it minus 3 after the number? Like you multiply the number and then you subtract 3?
I don't know what you think it was.
Oh.
No.
No?
No, what number do you multiply by?
3.
So times 3 minus 3?
Yeah.
Well, does that work?
No.
7 times 3 is 21.
Yeah. Oh, it does.
3 times 1.
Good job.
3 minus
9 times 3 is 27. 3 times 3 is 9.
Yes.
So let's plot it. So 4. So let's do 7 and 18. 1 and 0. 1 and 0 here. 9 and 24. None of it's off the charts. Right there. And 3, 6. So another point right here. 3, 6 got hit twice. Interesting. Getting the hang of this?
I get the
I get
graphic,
it.
I don't get the cutting and illustrating.
Well, what it is for you, if I multiply the input by 3 and subtract it, that's what my output is. So 7 times 3 is minus 3. So that was the pattern that he noticed. Okay, so last one.
I got a number that nobody's picked yet. I'm ready.
He's ready.
Okay, what's the input?
5.
Dean, 5?
Yep. Going hard on the
You sound so proud.
That's a solid number, dude. I like it.
Voice? Brian.
Negative 9. I actually got 2 shots back to back.
Yeah.
So obvious when it was the rest of my
Nicholas? 6. 6?
Yes.
This
Yeah.
is so boring.
Yeah.
Well, you only give us like 10 numbers.
I know.
Yeah, just say it.
I got it.
Oh.
Negative 11. So input 6, output negative 11.
2.
Christina, 2?
Oh, I know. See, now
I
I
know
know
what
you.
this is.
Negative 3.
Yeah, that's easy.
Why? So I got it from the first.
Okay, so some of you say you got it. Let's confirm
I got it.
for the last one. Who wants to pick the last number? Matthew.
10.
10?
Why do you always do that?
You ruined it. Oh, can I guess it, Mr.
Yeah,
Tim?
you're yes.
No, can I guess it?
Sure.
Negative 19.
No.
Or, I think.
Yeah. Smart kid.
Yeah.
Who's this first one?
That was good.
Sorry?
What?
I got it since the first one.
How come nobody chose 0?
Oh, I get it.
0 was confusing
Oh, really?
everybody.
0 doesn't
No,
confuse
you
anyone.
said only
Yeah,
put
0
one.
times negative 2 is
No,
0.
It's 0 to 10 inclusive.
No, I thought you said 1 to 10.
Zero to
I would take 0.
So here, let's plot these ones. We have 5, negative 9. So 5, 9 down, brings here. 6, negative 11. Oops. So 5 was negative 9, right? 6 was negative 11. What was the next one?
We're doing negative.
2 and negative 3.
You have to draw a line with us, because that's going to be a really. Not anything.
And 10 and negative 19.
That means we are going to have to draw a line with us.
Okay. So we got those 4 graphs. Yes?
Wait, if it's going negative, which one is it going?
Well, the input was still, right, 5. So in this one went 5 over. And then it goes negative 9 down, which brings us to here. Okay? So instead of going up before, now we go down because it's negative 9. Because the negative values are below our x-axis. So I have a question. What is the relationship between these graphs on the points? Between the input and output? So in each of these graphs, what have you noticed about the relationship?
Oh.
So what do you notice about the relationship about each of these scatter plots between the input and output? Or you guys wrote this test and just trying to regurgitate some information from you guys, right? Don't delete it all yet. You need it. So what do you notice about the relationship between the input and output from these scatter plots? Paul?
It's linear.
There's a relation.
Hashtag late.
Sorry, whoa. What could you decide?
So what is the relationship between these 3 points in these graphs? So Paul said it's linear. Right, they look pretty linear. What else do we see about this between input and output?
Are you looking higher?
No, you have scatter plots. So look at that 4 of your scatter plots. What have you noticed? Anthony? Have a pattern. What's that pattern? What's the trend? What's the pattern or what's the trend that you noticed? Okay, so it's almost exact. Right, so that's kind of looking for. What else do we know about the relationship? Well, Paul said it was linear. Was it a weak correlation or a strong correlation?
Strong.
How come it was strong?
Because it was just like all the
Well, it looked very much like it would be if we drew a line of best fit going right through them, right? It was a strong correlation. Okay. So I'm gonna change the program a little bit, right? What would happen if I no longer allow integers, but I also allow decimals? So I still have the same range between 0 and 10, but now you can input a decimal, any decimal. It could be to any decimal you could think of, between 0 and 10. Okay? So what would happen? What would happen with this graph when you do your scatter plot? Think about what would happen if you scatter plotted every single entry that you put in for x, where x is between 0 and 10, and it could be any real number, any decimal. What would your scatter plot start to look like? What would it look like? Bad. Jenny? Yeah, they're going to be really close to one another, right? So if I give you like 0.01, right, and I plot y for that, it'll be very close, right? And then do like 0.02, do 0.03, and so on and so on. If I ask you just to plot that on the same graph here, they'll be really tight together, right? Conceptually, what's going to think is going to happen? Right, so we see this relationship with input and output. Now our input can be a real number, any decimal. What do you think your scatter plot is going to look like? You guys try to envision it? What's it going to look like? What's it going to look like? Nobody else? Just Jenny and Paul? Nobody has an idea what it might look like? It's non-linear? Maybe. Okay. Jenny?
I was gonna say, it might just look like a line because it's so close to each other.
Yeah, they're going to be so close to one another, and they're following that pattern that Anthony noticed, right?
Yeah.
And we notice that it's a linear pattern, right? It's going to start looking like. So if I took every single decimal number between 0 and 10 and plotted it, this is what it's going to kind of look like. So one thing I want you guys to start having for this class, for this unit, is rulers. Okay? What's going to happen is that you get started things that look like a line. So I have here. I can change the color on this as well. Green with my green dots right here.
Can you do all of the
When x was 2, y was negative 1, right?
Yeah. No, when x was 2 and y was negative 3. For the last
Or was it
one.
negative 3?
Yeah, because it was times 2 and that's 1.
Oh, times negative 2.
Yeah, times negative 2.
So 5 was 9, 6 was. Okay? So what would happen is if we took every single possible decimal in between and actually plotted each one, we'll start looking at that. Now, is it feasible for you to actually plot every single decimal?
No.
No.
What is the,
Is it practical? Is it even possible? Right? How many decimal numbers are between 0 and 10? Infinite amount. Okay? But when we look at this, that's what a line really is. And I want you to conceptually picture that. Because my students in grade 10, they're confused with that right now. And I had to backtrack. And then some of them are still not getting this conceptually. So this is important. A line is an infinite set of dots. Okay? It's as if you took your pencil and you dotted that thing 1 billion times. You get what looks like a line. But conceptually what it is when we have a value of an input, we have a value for the output. Right? We have a value for an independent variable, then we get a result, which is our dependent variable. And we're just scatter plotting that. But if we're going to scatter plot every single possibility, what comes now is we do get a line. Okay? So what happens if I remove the restriction that has between 0 and 10, and it could be any real number?
Oh god.
that would suck.
That would suck, but what would happen to our graphs?
It'd be pointless.
Not quite pointless.
Well, I mean, it would go
What would happen to our graphs? Not turn black.
Well, yeah, technically.
What would happen to the graph? What happened to the graph of each of these? If we allowed it to be any real number now, past
with the
10,
same scale,
zero.
would we change the scale, Mr. Tim, or would we keep it the same?
just keep right here, Nicholas.
It would be more spaced out.
It would be more spaced out. This exact same graph here, what I have, now I allow more than 10 or less than 0. Yeah, it just keeps going, right? So basically the graph would just extend. Right? All we do is that line just keeps going on and on and on forever. But it goes in the same direction, the same, how can I describe it? The same direction, same angle, same slope. Throw that out there, right? So you just draw it as long as you can. Because now you allow infinite amount of possibilities for your input. Okay? Any questions on this? So what we're starting to discover is that some things behave in a very linear fashion. We sort of understood what that meant last unit. Now we see that some things behave in exactly a linear fashion. In other words, if we drew a line of best fit through these dots, it actually goes through all these dots. Let's go back into here, and let's just formalize what we have. So we said that the output was what? What was it for the first one?
Hold on, it was times 2 plus 3.
So it was the input times 2 plus 3. Right? So I could rewrite this as O is equal to 2I plus 3. O being short for output, I being short for input. what would my equation look like over here? What was the formula? What was happening? What was the program there on the second one? How do we get the input? Sorry, how do we get the output? What was the formula? What's the calculation of it? Anthony? What times what by 2? Yeah, so the output was just basically 2 times the input. Okay. What about the bottom, this one here, the third one?
Wait, did that say 2i?
2i. So I is short for input, O is short for output. Thanks?
It was the input times 3 minus 3.
So output is equal to
Input
times 3, so 3i
minus 3.
minus 3. Right? And what about the last one? What was the equation that was happening in there? What's the computer program doing?
Oh, times -2.
So output is equal to minus 2i plus 1. Okay? So basically now I could give you any value for your inputs. Let's say for this program, the last one, I could give you a value of 1,000. What's my output?
What?
For the last one. So I give you the input of 1,000, what's my output? Now how'd you get that? So that's negative 2 times 1,000 gives me negative 2,000. So we're adding one. So it's negative 1,199. Okay? So here we're dealing with equations now. So how is this gonna make practical use of this? Let's say I ask you this question. Dean gets a part-time job. Can't be this Dean, because this Dean actually does work. So Dean gets a part-time job in nearby Tim Hortons. He earns $11.50 an hour. So determine an equation to calculate Dean's pay and illustrate the relationship graphically. Okay? So how can we determine an equation for Dean's pay? Well, first of all, before we get there, let's define our variables. What's our independent variable?
How much I
Hours worked.
Hours.
Which is also your input.
So that's a good way to think about it. It's the input. So independent variable here is what?
Hour. Dean.
Oh,
What'd you say, Dean?
Dean, what did you say?
Oh.
for Dean?
Yeah, what was the independent variable?
I said the money per hour.
The money per hour?
Yeah.
Okay, well that one doesn't change, right?
Yeah, it's what Paul said. It wasn't what I said.
Well, what did Paul say there?
Hours worked.
Hours worked, okay? So it's good to note that it's not 1150, that's not the independent variable because that one doesn't change. When the variable changes its value, right? So $11.50
It's just
doesn't change, that's the rate that we're paying Dean. No more, no less. So the independent variable is what, that's the one that's going to affect his what, so what's our dependent variable? Dependent variable. So what's our dependent variable? Okay?
The money.
Yeah, or his pay. Right? So here we have pay as the dependent variable. So we usually go like this. Dependent variable P, the pay, that's equal to something that our independent variable is going to affect this, right? But what is that relationship? How can we classify that relationship? How do we determine his pay? How do we determine Dean's pay? I know he does. Anybody else? Vincent?
Well, maybe every the hours
Right?
with how much he earns. So it'd be
Hours? So how does hours affect his pay? So let's say he worked 1 hour,
Well, that's then he gets $11. So
or 11.50, right? But how do we determine? So we could draw a little table of value here, where we say hours and pay. So here we have 1 hour. What's his pay? After 1 hour, 11.50. What's his pay after if he works 4 hours?
1150 times 4.
So what would that be?
$43.
$43?
Oh no, wait, no. 47.
No, 40, no, yeah, 46.
Good. See, notice that when Dean is getting paid, he's going to do his math correctly.
Yeah, I guess, I want my money.
46. Well, how do we get 46? How do we determine that he actually, how much he get paid after 4 hours? What was the formula that we used?
You
Christina?
multiplied the amount he was paid by an hour by like how many hours he worked.
How much is he getting paid by hour?
11.
Right? So we usually take hours times 150. Right?
Okay, you just instead of saying hours, can't you realize that so your independent variable is your input, your dependent variable is your output. So instead of hours, can you just write I?
Well, what we're going to do is,
For pay, you can just write O, so it's O equals
I'm going to come up with other variables. P is equal to 1150 H.
So we don't use input and output here, we just use
No, we'll use a little bit more specific or more meaningful names.
So but this is only on word problems, right?
No, just in general. Right, what are we representing? It turns out to be variables, word problems. Right? If we weren't dealing with word problems, what's our intermediate variable usually named? X. What's our dependent variable usually named? Y. So normally we have y is equal to something x. So how will we graph this? Well, I do a scale here. Let's do 1, 2, 3, 4. And for this scale, let's do 23. 34 is 23, 46. Yes, ma'am.
The graphing, does your input and output scale have to be the same?
It just happened to be in that case, yes, because that was my formula.
But like,
Oh, and that one?
yeah,
no.
like if I went up by 2s for the input thing, do I have to go up by 2?
No. The x and y's don't have to be the same.
Okay, but
They
then
just have to be consistent within each other. Okay? Question? Yeah. So how would I graph this? Well, if he gets paid, sorry, if he works 0 hours, how much does he get paid?
0 money.
0 money. If you work 1 hour, how much does he get paid?
11.
11.50, which works here. If he works 4,
I get 46.
No,
46. Which brings us up to around there.
Which one I just call after me to do.
Right? Now if I do a line of best fit on here, what's happening is that it's not really a line of best fit, it's actually a linear equation.
Can't we just
Well,
use
that's
more
gonna
points
show
and create a
where
line?
my money is.
Show Dean the money.
Okay? So this is where you take up this straight edge and you connect your dots, right? And with that straight line, you pass through every single dot that we just plotted. Okay? So you don't have a straight edge, take out your badge. That works pretty good. I want to see straight lines. Now, so you're going to lose technical marks when I'm evaluating you.
But I think the test for my grade.
You will.
What?
Okay?
Well, last year was
That was last
So on this graph, we could actually read, well, if Dean worked 3 hours, how much money is he going to get paid? It's going to be right there. We can see that 3 hours, he's going to get paid that much.
And how much is that?
I don't know. Looks like
Dean's only
34.50.
Not bad.
Okay. So here's a question. 1 week, Dean worked 15 hours. Do I get 15 on my grid? No, that's I can do is up to 6. But I can calculate how much Dean is going to earn working 15 hours. How can I do that? How can I calculate how many hours how much Dean is going to get paid for 15 hours work?
How much is that?
15 hours. 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 15 hours.
There's two ways.
Minutes.
There's the equation.
Okay. So what's our equation?
Pay is 1150 times how many hours you work. So that'd be 50 now.
We just plug in 50. P is equal to 1150 times 15. So what's his pay? So we take our calculator, 15 times 1150.
Using my grade. And that is 172.
172.50.
I knew it. I'm making money.
Okay.
Exact same.
So given the input, which was the hours worked, we could figure out his pay. Okay? Now how do we answer the other question? The next week, Dean earned $109.25. How many hours did he work?
Well, that doesn't make sense.
Why doesn't it make sense?
Bro.
Switch it up.
Because how do I make 25 cents? Do I work half an hour?
Yeah.
Well, how can we go off and calculate this number? Following week, Dean earned $109.25.
No, there's
How many hours did he work? How can we go off and calculate that?
Oh.
Well, do we still have the same equation
Yeah, no.
to calculate Dean's pay? Has his pay changed?
No.
So let's just start off with that equation.
Trying to find the H.
G is equal
P
to
divided by
1150.
150.
That's H. Do you know the hours worked?
No, we're trying to
No,
find
that's
the
what we're trying to find.
So you divide it.
So what's his pay?
P divided.
Oh, we know that, $109.25.
Divide that. I didn't work that much this week.
So hopefully we can see why that unit on solving equations is so important now. Because this is what we're doing now. Right? So we start with two variables, equation two variables, we know the value of one. Now we need to do what with H? What is it? Isolate for H, right? To get the value of H. So in this case, how do I isolate for H? How do I isolate for H? You guys did well in this equations test, I know you did. Right? How do we isolate for H in this case? Well, if I multiply both sides H, I just gonna get H on both sides now. How do I get H by itself? Remember that's what isolate means. How do I get H by itself? Brian.
You move 1150 to the other side of the
Well, we're not adding 1150, right? So if we're adding 1150, then we would subtract 1150. But here 1150 is being multiplied to H. So what's the opposite of multiply? So we want to divide both sides by 1150. Right? Remember our rule. Do one thing on one side, we have to do it to the other side. Right? So what's the value of H then? What's 109.25 divided by 1150? What's 109.25 divided by 1150? Did you get it, Katie?
Yeah, I should go for
Oh, 9.5.
9.5. So therefore, Dean worked in 9.5 hours.
I got those down.
Because he was busy studying for his math test.
Yeah. What can I say?
Okay?
Education first.
Any questions on this? Any questions on this? Can you wait? Like 15 minutes? If you can't, then go now. Hurry. Or hurry.
Right, move fast.
Okay, any questions? Okay.
Show us how to get to the video info first time. Olympic was
So let me tell you a bit of history. The cell phones. So way back when cell phones became somewhat popular, wife and I signed up for a plan.
And it's skyrocketed.
Back then, it was actually a pretty good plan for back then. $20 a month got me 100 minutes of talk billed by the second, right? Used to bill, most plans back then billed by the minute. That means if I talk for 1 minute and 1 second, they charge me for 2 minutes. So this was actually pretty good. It billed me by the second. I got 100 minutes. And I don't talk a lot on the phone, so the service is just right. Then all of a sudden this phenomenon came around of texting, right? Of course, my plan had nothing to do with texting. Texting wasn't even invented back then, right? So all of a sudden texting came around. I said, well, whatever, I don't text, I don't need it, I'm not changing my plan, right? I'm never gonna text anyone, even though, when I upgraded my phone, it had the ability to text. Fine. And all of a sudden I started receiving texts from people, it's almost like cold calls, like advertising, junk mail, right? We get texts. My friends would start texting me, hey John, it's so calm tonight. I'm like, whatever, I'm gonna ignore it, because I'm not into that. But they didn't charge me, it's fine. But then all of a sudden, the government or CRTC decided they allowed the telephone companies to charge people for text.
The receiver?
The receiver,
That sucks.
35 cents was the standard rate. 35 cents for a text. Even though I didn't text it, if someone sent me a text, I get charged 35 cents. I was like, what? I said, that's fine. People don't text me. People still texted me because that was the thing. You get these advertisers texting me, and I had no way to turn this thing off. Like, I couldn't tell the company at the time, I refused to accept any texts, right? They just let it through because to them it was 35 cents every time somebody texted me. They didn't care. 35 cents. So that was my thing. So my plan back then was $20 a month. That's what I had to pay. So then I had to pay 35 cents for text. So if somebody texted me 10 times that month, what would my phone bill be? So 10 texts in a month, what would my phone bill be? Sorry?
23.5.
$23.50?
$3.50. 35 cents.
Sorry, 35 cents a text. There's actually a decimal in there. 35 cents a text, and I got 10 texts that month. How was my phone bill?
$3.50.
No, my actual phone bill. What's my actual phone bill?
23.50.
Yeah.
$23.50?
Yeah.
How'd you guys get $23.50?
20 plus $3. $3.50 plus $20.
Well, how do I get? Sorry, how do I get $23.50? Christina?
So the text itself would be 10 times 0.35 would be 3.5, $3.50.
So the text was what? 35 cents times 10.
Yeah.
So that's $3.50.
Yes, and then because you already have $20 in the plan, you add on the fee.
Right. So that gives me $23.50. So what's my equation here? So my bill is what? Well, how much do I have to pay regardless if I receive a text or not? What happens if I get 0 text? What's my bill? $20. But how much do I have to pay on top of each text? 30 cents. So it's really, plus I want to add 35 cents for each text. The number of texts, I have to add, multiply by 35 cents. So really, the equation could be B is equal to 20 plus 0.35 T, right? So $20 I paid regardless, because that was my plan, and then I have to add in 35 cents for each text. So that's how we sort of did our formula, right? That's how we did it with Christina. So how much would my bill be if I had 22 texts in a month? What happens if my buddies start texting me and say, hey, you free tonight, play some NHL 13, right? That's how they communicate. Coming online tonight? So if I have 22 texts in 1 month, which isn't a lot, that's less than one a day. What will my bill be? So how do we work it out? B is equal to, I'm playing 20 regardless, right? Plus 35 cents, and how many texts am I getting? 22. So what's 35 cents times 22?
27.7.
Well, what's 0.35 times 22? 7.7? So basically my bill would be $27.70. What happened with 49 texts? How much would be 49 texts? How can I calculate that?
37.
So we plug it in our calculators, right? 49 times 0.35,
$17.50.
$17.50 in tax.
Yeah. No.
So my bill would be $37.50.
No.
About 15.
Yeah, wouldn't it? I don't know.
49 times 0.35. You don't have a calculator. You have a calculator. Take it out. Go to your calculators.
Yeah, exactly.
1750? Okay. So that's if I got like 1.5 texts a day on average. What happens if I got 40 texts a day? What's my phone bill?
A lot.
40 texts a day?
It's 17.
A little really expensive.
Oh, just
That's
do-
just for the text, but that's not to pay $20.
How many days per month?
How many? What month?
Oh, 15.
What month is it?
Let's say in a month or 30 days. I mean, 40 texts a day, you know what? That's not a lot.
So 70.
If I had 8 friends, okay, I don't have that many friends. Let's say I have 5 friends, and they just texted me 8 times. And you know what? It's a two-way. If I text them back, that costs me 35 cents. So,
Why are you twisting our brain?
hi, sends. It's cost me 35 cents. Hi, question mark, 95 cents. What's up?
I hate those conversations.
Notice that, see how 8 texts can add up pretty easy between 5 friends. So if I average 40 texts a day, how much would this cost me?
440.
What's that for?
$440.
That's only for a month. So times out by 12, that's what we paid for a year.
No, plus $20.
Yeah. Add 20 times it by 12, that's what we paid for a year.
All around. You're not gonna have the same.
It's pink, it's pink.
Okay, so my formula for that is bill B, so 20 plus, so what's my formula, 0.35?
Yeah.
So how do I figure out how many texts there are?
40 times 30.
40 times 30. So what is that equal to?
12.
20 plus what? So what's 0.35 times 40 times 30?
12. No,
Okay,
that's
1200 times 0.35.
wrong. 405.
$420?
No.
Why are we talking about
440, actually.
That's a day. They get 40 texts a day. How many days in a month? Roughly around 30. So I'm paying $440 for this bill.
Wow.
Wait,
That's a lot of money.
wait, every day?
So you say you get
Well, because the bill is a monthly bill, right? So this is how your cell phone bill can quickly add up when you don't have a real good plan. So I quickly changed my plan. And we'll talk actually at the end of this unit, the next unit, on what the best plan for you would be. And we'll do this through math. Right? So I have another question. 1 month, my bill was $23.50. Stay with me, guys, okay? Stay with me. One month, my bill was $23.15. How many text messages did I get that month? So how do I go about solving that? So one month I was billed $23.15. How many text messages did I get billed for? How many text messages were charged to me that month? How can I figure that out? Rita?
It was $23.15.
$23.15.
Alright, so $23.15 equals 20.
Okay, so first I'm gonna start off using our equation up here. Right? So B is equal to 20 plus 0.35 T. So you said the bill was 23.15?
And then, you divide the T.
Well, we don't know the T, right?
Yeah.
So that
Oh,
just
sorry.
stays the same. So now what is it that we're solving for? Yeah, now we're solving for T, right? So I could have gave this exact same equation 2 units ago, right? Solve for T. Now we're hopefully drawing that connection, why that unit is so important. So how are you gonna solve for T, please?
Well, you subtract 20 from each side,
Good.
and then
For
you divide.
0.35 T.
Would you divide?
Well, let's simplify this first. So I got 315 for 0.35
And then
T.
you divide by.
So how do I isolate for T?
And then you divide the 0.35 on both sides.
Good. So T is equal to what? 3.15 divided by 0.35.
So,
3.15 divided by 0.35.
Oh, okay.
Nicholas? Are you guessing or you know for sure?
Oh, it's not Larry.
Oh, okay. So 9. So therefore 9 texts. That's a good. Thank you, Sarah.
You're welcome.
Okay? So here we can use linear equations to help us figure things out that behave in a very linear fashion. Okay, so any questions for the last 2 examples I did? Regarding Tim Hortons, Dean working at Tim Hortons, my cell phone. Okay, take down these notes. Key concepts. You guys weren't writing down my cell phone example? You should be writing down the notes. There's a reason why I'm up here. It's not for your entertainment. As entertaining as they may be, it's not. I'm up there for you to copy down the notes. So the key concepts that you need to get from this lesson. We have this thing called direct variation. The direct variation is a relationship between 2 variables in which one variable is a direct constant multiple. It's a multiple. Is a direct constant multiple, that's known as a constant of variation of the other. And with this, the graph passes through the origin.
What's the origin?
The origin is 0, 0 in our graph. I'll write that in here. In other words, when our independent variable has a value 0, our dependent variable has a value of 0, right? That's what that coordinate pair means. Independent, dependent. Okay. And there's also this thing called, everybody finish writing this down? Direct variation. Partial variation. It's also indirect variation. A direct variation, but with an initial or fixed value. So in this case, the graph does not pass through the origin. In other words, when the independent value is 0, the dependent value is not 0, it's something else. So let me ask you this. When we did our computer program, which one of those was a direct variation? Which of the 4 examples was a direct variation? In other words, which one of those was just a straight, direct, constant multiple of the other? Not quite. Just a straight, constant multiple. So which one of those examples of computer program was just a multiple of the other? The output was just a multiple of the other. That's all it was. All?
The second one.
The second one, where was basically output is equal to 2 times the input. That was the only one that was a direct variation. If I plugged in 0 for x, or for the input, what is my output? 0, right? We're going to pass 0 through 0. The other 3 were examples of partial variation. Okay? Where basically if I plugged in 0 for x, and that's always interesting, nobody picked 0 for the input. If I plugged in 0 for x, I would not have gotten 0 as an output. In the example between Tim Hortons and the cell phone, which one was a direct variation? Which of those 2 examples was a direct variation? Tim Hortons? How come?
Because the cell phone depends on how many texts. Yeah.
Right, but Tim Hortons depended on how many hours you work.
Yeah, but the hours is constant.
So was my tax 35 cents.
So I don't know why.
So, what was the implication of it being direct? 0, 0 goes through the origin. So if you didn't work, Dean, how much did you get paid?
Nothing.
Nothing.
0,
Right.
0.
Oh yeah.
By my cell phone bill, if I didn't text, how much was I charged?
20.
Still 20,
Oh.
right? That's why that's a partial variation.
250.
So in general, the equation with the form y is equal to mx plus b models both direct and partial variation. So instead of here being an O, we just have a y. Instead of x, instead of I, we have x. M is just that number that we multiply it by, right? So in the computer program, the first one we multiply by 2. The second we still multiply by 2. Third one we multiply by 3. Fourth one we multiply by -2. So m is that value that we multiply things by. M is your constant of variation. Okay? So m is your constant of variation. Where m represents the constant of variation and b represents the initial or fixed value of y. So when V is 0, that means we have a direct variation relationship. Right, and we saw that in the Tim Hortons example, right? It was just 1150 times h. We're adding or subtracting it. Any questions on this? So this is your homework. I apologize for not giving you enough time in class to do this, but really, I've looked at it, it's like 10 or 15 minutes. It sounds like, look like you guys are understanding the concept, we'll see, this will reinforce that. 10 or 15 minutes is posted on Blackboard already. So like the equations unit, wasn't that hard on you guys last unit. But like the equations unit, homework every day, pictures, Google presentation, I'll be taking a close look. This is a very important unit for future
What is the student for?
linear relations.
Besides you.